Okay, now you add 100 millimoles. 100 millimoles, right? Same kind of deal, but then you generate all products. Virtually zero left. So now what is the pH? You know, you don't get a ratio to calculate. So now all the HA, your analyte, becomes A minus. Okay, so it's all that, so 100 millimoles of that. Then what is the pH? It's not 7, right? At the end point, it's not 7. Notice you have this guy in solution. It's not neutral. Once you have this, it's alkaline, right? So to follow up that statement, here is a verification. So all that becomes this. So now assume that you prepare a solution by dissolving this guy. Okay, you add this guy in water. So isn't this condition the same as your endpoint, right? So they are the same. So your endpoint is this solution, as if you dissolve this chemical in water. So this is your equilibrium expression we talked about previously. So this is going to be your Kb. Okay, so the endpoint is going to be higher than pH 7. So how do you get the Kb from? This relationship. Okay, so Kb, you know, Kw over Ka. The Ka, let's say, is 10 to the minus 5, and now you get the Kb to be 10 to the minus 6. So now this is x, this is x, this is whatever. The 100 minus x, you know, because this is so small, then that x is negligible. So on and so forth, then you calculate for pOH, get to the pH. Okay, there should be one more point. Somehow it's here. Okay, so that was the end point. So at the end point, we just learned how to calculate the pH. Any question for the end point calculation? Now it's beyond the end point. Beyond the end point, you put in excess drop of OH minus, and it's a strong base. So even though that split drop is that tiny, assume this is the plus minus for the direct uncertainty. So you put this quantity in, then even with that calculation, you know, like 2 times 10 to the minus 2 milliliter MV, the 0.1 molar, then liter, then you're going to put in 10 to the minus 3 millimoles. Then you calculate the total volume, you know, that millimoles over so many milliliter to get the concentration of the hydroxide. So what it amounts to, you calculate pOH based on the excess amount only. Then it will be fine to calculate that pH. Any question at this point?
Should there be 2.5 times 10 to the minus 2?
Yeah, it should be 2.5.
Okay.
Yeah, but I just say that for illustration, I just keep it with one significant figure. Okay, so your homework here, due a week from today. Okay, have you written down the homework?
No.
Yeah.
So after you exceed the endpoint, when you're determining X, it's POH that you're determining at that point, right? So then you have to go reverse to get pH. Is that right?
That's correct. Yeah. Because your titration curve is pH versus the volume titrant atoms.
Sorry, can you go back for a sec? The homework. Can I see the homework one more time?
Okay, then I need to escape.
Oh, sorry.
That's fine.
If you right click, you can go back on when you're in slideshow.
Yeah, theoretically, but then it doesn't work. Just like I did not want to skip, but then I press it one time, then it skipped. Okay, you're welcome. Okay, the magnitude of Ka on the titration curve. Now this is your general log for the titration curve, and you calculate based on what we did earlier. Then this is the curve you're going to generate. Now Ka has a magnitude, right? And how would that affect the log of the titration curve? Okay, this is a general log. Then you will get, in terms of magnitude, different magnitudes will give you different spread before and after. So point number one, the larger Ka value will give you the lower buffer region. So this is the largest Ka, okay, of the three. So that is point number one. So if this is largest, then your endpoint before and after. So the spread, the larger the spread, the sharper the endpoint. Okay, so the largest Ka will give you the sharpest endpoint. Then point number B is, of course, the sharper the endpoint, the easier to identify it. Okay, so the larger Ka will allow you that to do. Then you will say that, follow A and B, then how low can you get and still be able to see the endpoint? All right, so things like this, then the endpoint may become fuzzier and fuzzier, So it turns out that for human eyes, the low limit is about 10 to the minus 6. Lower than that, if you do a 10 to the minus 7, then you may not see the color change. Okay, so there's a low limit, 10 to the minus 6. Now, that is for human eyes to see. If you employ non-human, like a pH meter, to trace the history, then you can you can extend the lower limit, okay, using pH meter. Okay, so that's for Ka. Now, if the titration is the reverse against a base, then it will be reversed like this. Everything is similar. Then the general log will be like this in case of strong acid against a weak base. Then in terms of magnitude, same deal. We are talking about Kb magnitude. So this is the lowest Kb, and this is the highest Kb, okay, before and after. So be careful when you reference to the K, then be sure you know Ka, Kb, they are opposite to one another. Okay. Then what about titration for a mixture? So far, we talked about just one acid or one base being titrated. Then what about a mixture such as that? HCl and a weak acid HA. It turns out that the stronger acid, the proton, is going to be reacted first. So remember the KL reaction kind of deal, you know. KL reaction is based on the Ka magnitude for the particular reaction. So the reciprocal is your KL reaction. Okay? So obviously HCl is stronger, is the strong acid. So the H plus from HCl is going to be reacted first. Until all those H plus been reacted, then this guy, the proton will come out to react with sodium hydroxide. Okay? So this will react next. Now in terms of titration curve, then we're all familiar with strong acid, strong base. We get a sharp endpoint with pH 7. Now with this titrate alone, then we get an alkaline endpoint, alkaline pH. Okay, now combined in a mixture. You're going to have, in this case, going to have two endpoints. Okay, with the starting pH to be intermediate between the two, and you're going to have two endpoints. Okay, how do you know it's going to have two endpoints? This is important. So in your notebook, write this down. Magic number, okay, you call it magic number, okay, call it magic number. It's a ratio between the two K values is at least 10 to the fourth, then you get two endpoints. Less than that, then you just the two mix together as one endpoint. Okay, so we will illustrate this point next. Oh, okay, well, okay, see you in the lab at 1 o'clock.